Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to find the area of shaded regions, which is a topic that occasionally appears in the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. As usual, I'm going to include timestamps in the description of this video. Those timestamps are going to be associated with each of the 5 practice questions in this video. And in light of that, I'll say this. If you're confident in your ability to find the area of shaded regions already, you can go ahead and click on those timestamps to skip ahead in this video, work out the practice problems on your own, and then resume playing the video to check your solution. Otherwise, I strongly encourage you to watch this video from start to finish. Prior to getting to the practice problems in today's video, I quickly want to review some formulas you need to know for the ASVAB. Again, on the ASVAB, you're not permitted to use a reference sheet or a calculator. And in light of that, I created a 13-page reference sheet that you can download from my website. My website is called asvabapp.com. On the left-hand side, you'll see a link to my reference sheet. I strongly encourage you to memorize all the formulas in that reference sheet. And for this video, we're actually going to need to know how to find the area of each of these common shapes. As you can see, we have a square, a rectangle, a circle, a isosceles triangle, and a right triangle. At this point in the video, I'd like you to pause the video and attempt to write the area for each of these shapes. In order to be successful on the ASVAB, you should be able to effortlessly write these formulas. So let's start with this square over here. Again, in a square, all the sides are equal, so that side's equal to that side's equal to that side, and that side's equal to that side. More often than not, we label the sides of squares with S's, so all the sides of a square would be S, 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 and S. To find the area of a square, we do side times side, and that's the same thing as side squared. So either of those two formulas is the way you find the area of a square. As far as rectangles go, there's only one formula, and that's length times width. Again, here's our length, and here is our width. To find the area of a circle, it's going to be area equals pi r squared, where r, of course, refers to the radius of a circle. Again, the radius is defined as the distance from the center point of the circle to the edge of the circle. And let me just stress this. Circles have quite a few radiuses because, again, the definition is from the center point to the edge of the circle. So that's one radius. If I go from here to here, that's another radius. That's another radius. That's another radius. And that's another radius. So when we get to question 5, that's going to be important to note. Again, the radius of a circle is defined as the distance from the center point of the circle to the edge of the circle. All right, so for these next two, we're going to use the same formula. Again, to find the area of a triangle, we use the formula area equals 1/2 base times height. And let me just say this. As far as this formula goes, nothing's going to change except height. Again, here's our base here, and here's our base here. But the height of triangles is always from the apex, or the highest point in the triangle, directly to the base. So right here is the height of this triangle. And in this right triangle, our apex is here, and a straight line down to the base is right here. So there's our height for that one. All right, so you should have been able to fill in most of those formulas. If not, you know you're going to have to work on memorizing those formulas in my reference sheet. But that said, let's go ahead and move on. All right, before we start this first question, I just want to go through these steps right here. These are not steps that you have to memorize. Rather, these are things you want to think about as you work your way through these problems. And the first step, as you can see, says list the individual shapes in the picture. So for example, in this first picture, we have a circle and a square. After that, it says find the area of each individual shape. So in this case, we'd be finding the area of the square as well as the circle. Then you want to ask yourself, do I keep my answer in terms of pi, or do I round? Well, let me say this. On the ASVAB, pi, for the most part, is always going to be 3.14. So for our purposes, we're always going to be rounding, and more specifically, we're always going to be using 3.14 to estimate pi. And then finally, you want to ask yourself, do you add or subtract? More often than not, when you're trying to find the area of a shaded region, you're going to be subtracting. Okay, so with those things in mind, let's go ahead and look at this first problem. Since we're starting the practice problems, I want to encourage you to pause the video, attempt to work out these practice problems on your own, and then resume playing the video to check your solution. So at the most, we're going to be finding the area of some common shapes and then either adding or subtracting. So most of you should be able to handle that on your own. That said, let's take a look at this first one. It says find the area of the shaded region. Again, as I mentioned, we have a square and a circle. Well, in order to find the area of the shaded region in this case, we're going to find the area of the square, and we're going to subtract that by the area of the circle. All right. Well, in general, how do you find the area of squares? If you recall, that was s squared. And in general, how do you find the area of circles? And that's pi r squared. Let's identify those things. We can see the side length of this square is 8, so we know s is 8. Let's go ahead and plug that in. This is 8 squared. Pi, what is the radius of this circle? Again, the radius is the distance from the center point of the circle to the edge of the circle, and we should clearly see that that is 4 in this case, so this becomes pi times 4 squared. Let's go ahead and work this out. 8 squared is 64 minus, what's 4 squared? That's 16, so this is 16 pi. Again, on the ASVAB, you're going to be told that pi is 3.14. So let's go ahead and replace pi with 3.14 now. This becomes 64 minus 16 times 3.14. And I'm going to work that off to the side. We have 16 times 3.14. As you can see, we're multiplying a whole number by a decimal. So to proceed, what we want to do is shift this decimal in 3.14 2 times to the right. And when we do that, this problem becomes 314 times 16, albeit with 2 decimals to shift back into the left at the end when we're done. Again, we move the decimals to the right here, and we'll move them back into the left over here. 4 times 6 is 24, carry a 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. So let's add these together. 0 plus 4 is 4. 8 plus 4, 8, 9, 10, 11, 12. Carry a 1. 8 plus 2 is 10. Carry a 1. And 3 plus 2 is 5. Bring our 2 decimals back in. 1, 2. All right, so we can see that this becomes 64 minus 50.24. And again, I'm going to work that off to the side so as not to make any simple mistakes here. This is 64 minus 50.24. And in order to perform this subtraction, I'm going to add a decimal after 64 and a couple of 0 placeholders. 0 minus 4 we can't do, so we have to borrow. When we borrow, we look to the left. Well, unfortunately, that's 0, so we can't borrow from it, so we're going to look to the left one more time. We're going to borrow from this 4. This is going to become 3, and this will become 10. And we're going to borrow one more time. This will become 10, or 9, and this will become 10. 10 minus 4 is 6. 9 minus 2 is 7. Drop down our decimal in place. 3 minus nothing is 3. And 6 minus 5 is 1. So the area of the shaded region in this case is 1376 feet squared. Again, area is always squared. All right, so that's that one. Pretty challenging. Again, you have to know your formulas, and you also have to be comfortable multiplying and subtracting with decimals. So good review of that too. All right, let's move on to the next one. So this one says find the area of the shaded region to the nearest tenth. Again, we're going to let pi be 3.14. So let's just take note of that. And in this case, it should be obvious that we're working with a big circle and a smaller circle inside of it. So in this case, to find the area of the shaded region, we're going to do area of the big circle minus the area of the small circle. Well, how do you find the area of circles in general? That's pi r squared. So this will become pi r squared minus pi r squared. And the only thing we have to do now is identify the radius of the big circle as well as the radius of the small circle. Again, the radius is defined as the distance from the edge of the circle to the center point of the circle. So the distance from here to here is the radius of our big circle, and we can see that that is 50. So this becomes pi 50 squared minus pi. What is the radius of this small circle? Again, here's the edge of the small circle, and here's the center point. We can see that is 36, so this becomes 36 squared. 50 squared is the same thing as 50 times 50, and likewise, 36 squared is the same thing as 36 times 36. So if you can't do those mentally, you can go ahead and work them off to the side like this. 0 times 0 is 0, 5 times 0 is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 0 is 0. 5 times 5 is 25. Let's add these together. 0 plus 0 is 0, 0 plus 0 is 0, 5 plus nothing is 5, and 2 plus nothing is 2. So this becomes 2500 pi minus, and let's work out this now. 6 times 6 is 36, so drop down to 6 and carry a 3. 6 times 3 is 18, 19, 20, 21. Before we start multiplication with this 3, let's bring in a 0 placeholder. 3 times 6 is 18, drop down an 8, carry a 1. 3 times 3 is 9, plus 1 is 10. Let's add these together. 6 plus 0 is 6, 8 plus 1 is 9, 2 plus 0 is 2, and 1 plus nothing is 1. So this is 1296 pi. And I'm going to work that off to the side so as not to make any mistakes here. We have 2500 minus 1296. Again, 0 minus 6 we can't do, so we're going to have to borrow from the left. We have a 0 here, so we can't borrow there. We're going to have to borrow from this 5. This will become 4. This will become 10. Borrow one more time, so this becomes 9. This becomes 10. 10 minus 6 is 4. 9 minus 9 is nothing. And then 4 minus 2 is 2. 2 minus 1 is 1. So this becomes 1204 pi. And at this point, we're going to substitute 3.14 in for pi. So this becomes 1204 times 3.14. And let's go ahead and work that off to the side now. Again, we have 1204 times 3.14. Again, we want to move the decimal in 3.14 such that 3.14 becomes a whole number. So we're going to move it 2 times. And we're going to go ahead and rewrite this like this. This becomes 1204 times 314 with no decimals. But once we work this out, we're going to have to move those 2 decimals back into the left. All right, so let's go ahead and take our time as we do this. This is a lot of work here. 4 times 4 is 16. Carry a 1. 4 times 0 is 0, plus 1 is 1. 4 times 2 is 8. 4 times 1 is 4. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 0 is 0. 1 times 2 is 2. 1 times 1 is 1. Before we start multiplication with this 3, we have to bring in 2 0 placeholders. 3 times 4 is 12, so carry a 1. 3 times 0 is 0, plus 1 is 1. 3 times 2 is 6, and 3 times 1 is 3. So let's add this together now. 6 plus 0 is 6. 4 plus 1 is 5. 8 plus 2 is 10. Carry a 1. 4, 5, 6, 7, 8. 1 plus 6 is 7. And 3 plus nothing is 3. Bring our 2 decimals back in. 1, 2. So this becomes 3780.56. That's going to be feet squared. Again, area is always squared. All right, so that's that one. Pretty difficult because of all this tedious math we had to do. I'll say this is the most tedious problem in this video. The rest of them are pretty straightforward, but I figured this question would give you a good review of multiplying with decimals. All right, so that's that one. All right, number 3 says find the area of the shaded region. And in this case, we have a big rectangle, and inside the big rectangle, we have a small rectangle. So to find the area of the shaded region in this case, it's going to be area of the big rectangle minus the area of the small rectangle. Well, how do you find the area of rectangles? That's always length times width. So this becomes length times width of the big rectangle minus length times width of the small rectangle. Let's go ahead and identify those. We can see that the length of the big rectangle is right here, it's 12. The width of the big rectangle is right here, it's 5. The length of the small rectangle is right here, it's 8, so that's our length. And the width of our small rectangle is right here, it's 3. All right, so this one's actually pretty easy to do. 12 times 5 is 60. 8 times 3 is 24. If you can't do this in your head, you can always do it off to the side. And again, on the ASVAB, you might be nervous, so don't feel guilty if you have to work this stuff off to the side. 0 minus 4 we can't do. We have to borrow. This becomes 5. This becomes 10. 10 minus 4 is 6. And 5 minus 2 is 3. All right, so the area of the shaded region in this case is 36 centimeters squared. All right, so that's that one. All right, so number 4 here says find the area of the shaded region. And as you can see, we have a rectangle, and inside that rectangle we have a triangle. So to find the area of the shaded region in this case, we're going to find the area of the rectangle, and we're going to subtract that by the area of the triangle. Okay. How do you find the area of a rectangle? That's going to be length times width. And how do you find the area of a triangle? Again, that's 1/2 base times height. So let's go ahead and identify those things. The length of the rectangle is right here. It's 12. So this becomes 12. Its width is right here. It's 4 minus 1/2. What is the base of our triangle? Again, that's right here. We know the base of this triangle is 9, so this is 1/2 times 9. And what is its height? Again, as you may recall from the beginning of this video, I said the height of a triangle is always from its apex to its base. So that would be from here, its apex, to its base. Well, what do we notice? That distance is the same as the width of this rectangle. So we know the height of this triangle is 4. All right, so let's go ahead and work this out. 12 times 4 is 48. Again, you have to know your times tables for this test. And I'm actually going to work this out the easy way. I'm going to take this 1/2 and multiply it by 4. 1/2 of 4 is 2, so this becomes 2 times 9. 2 times 9 is 18, so this becomes 48 minus 18. And if you can't work that out mentally, there's no shame in working it off to the side like this. 8 minus 8 is 0. 4 minus 1 is 3. So the area of the shaded region in this case is 30 centimeters squared. All right, so that's that one. Nothing too difficult there. All right, so if you've watched any of my videos, you should notice that I always start with easy questions and end with challenging questions. And that's no different in this video. Number 5 is probably going to be the most challenging problem for most of you. That said, if you think your way through this one logically, it should be very easy to figure out. But number 5 here says, what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they are inscribed by a rectangle. Use 3.14 for pi. All right, so let's identify our shapes. The problem told us what they were. We have a big rectangle and two identical circles. So to find the area of the shaded region in this case, we're going to find the area of the rectangle, and from that we're going to subtract the area of the first circle, which I'm going to call area circle 1, as well as the area of the second circle, which I'm going to call area circle 2. All right, so we can actually simplify this. Again, those circles are identical, so their areas are going to be the same. So this becomes area of rectangle minus 2 times the area of either of these circles, and I'll just use circle 1 in this case. All right, well, how do we find the area of rectangles? Again, that's length times width. How do we find the area of circles? Again, that's pi r squared. We happen to know the radius of our circle in this case. It's given to us in the problem. The circles have a radius of 5 inches, and we can also see it's right here. So let's go ahead and plug in r. We know r is 5 in this case. So this becomes length times width minus 2 pi. R is 5. So we'll plug in 5 squared, and we'll leave that in parentheses. All right, now the hard part about this problem is figuring out what length and width are. That said, I kind of hinted at how you're going to do this at the very beginning of the video. If you know the true definition of radius, this should not be too difficult to do. Again, what is the definition of radius? It's the distance from the center point of the circle to the edge of the circle. So the distance from here to here is a radius, and we know the radius is 5. Likewise, the distance from here to here is another radius, and we know the radius is 5. Well, the distance from here to here is the same as the width of this rectangle. So we should be able to say that the width of this rectangle is 5 plus 5 are 10. Again, using the definition of radius, we can also figure out the length of this rectangle. Because again, from the edge of the circle to the center point is the radius. So from here to here is another radius, and we know the radius is 5. Let's put a center point in this circle. Again, from the center point to the edge is another radius, and we know that's 5. And then from this edge to the center point is another radius, and we know that's 5. And clearly, the distance from here to here is the same as our length. So our length is 5 plus 5 plus 5 plus 5, which is 20. All right, so let's go ahead and plug those in. We know we have a length of 20, a width of 10, and that's going to be minus. Let's work this out very quickly. What is 5 squared? That's 25, so this is 25 pi. All right, let's work this out. 20 times 10 is 200. And what is 2 times 25 pi? That's going to be 50 pi. Again, we're going to let pi be 3.14 according to the problem. So this becomes 200 minus 50 times 3.14. All right, so we have 200 minus 50 times 3.14. I'm going to work out 50 times 3.14 off to the side so as not to make any mistakes here. Again, that's 50 times 3.14. And as we've seen in this video, we want to shift the decimal in 3.14 such that 3.14 becomes a whole number. So we're going to shift it 2 times to the right. And this actually becomes 314 times 50, albeit with 2 decimals to shift back into the left. All right, so let's work this out. We have 4 times 0, which is 0, 1 times 0, which is 0, and 3 times 0, which is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 4 is 20, so bring down a 0 and carry a 2. 5 times 1 is 5, plus 2 is 7, and then 3 times 5 is 15. Let's add these together. 0 plus 0 is 0, 0 plus 0 is 0, 7 plus 0 is 7, 5 plus nothing is 5, and 1 plus nothing is 1. Bring in our 2 decimals, 1, 2. So we can see that 50 times 3.14 is 157. Now all we have to do is work this out. We have 200 minus 157. And we start by saying 0 minus 7, which we can't do, so we're going to have to borrow from the left. Can't borrow from 0, so we're going to have to borrow from this 2. This will become 1. This will become 10. Borrow one more time. This becomes 9. This becomes 10. 10 minus 7 is 3. 9 minus 5 is 4, and 1 minus 1 is nothing. So the area of the shaded region in this case is 43 square inches. All right, so that's that one. All right, so that's it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Stress this again. In order to be successful on the ASVAB, you do have to memorize formulas. On my website, I have a free 13-page reference sheet that you can download today. So there's no excuses in that regard. If you want to support my channel, please consider subscribing to it. But on that note, I'm going to go ahead and cut you loose.
こんにちは。